right, we have a motorboat starting from rest with its initial velocity v of 0 equal to v naught equals 0. Its motor is providing a constant acceleration of 4 feet per second squared, but water resistance causes a deceleration of v squared divided by 400 feet per second squared. We want to find v, the velocity, when t, the time, is 10 seconds, and also find the limiting velocity of this boat. So we're going to start by setting up the total acceleration. So our acceleration total equals a positive 4 from its motor, and then a minus v squared divided by 400 feet per second squared due to the water resistance. And so we want to take this and just rewrite the acceleration as the derivative of velocity with respect to time, so that everything is in terms of velocity here. We're going to go ahead and take this and multiply both sides by 400 to clear out the denominator. And when I do that, we will go ahead and get a 400 dv dt equals 1600 minus v squared. And now we want to use separation of variables in order to be able to solve this differential equation. So what I'm going to do is I'm going to divide the 600 minus v squared to the left and multiply the dt to the right. And then we need to integrate both sides with respect to the given variables. Now the 400 divided by 16 minus v squared, in order to integrate that, we need to use partial fraction decomposition. Partial fraction decomposition. And so I'm going to take that fraction, I'm going to go ahead and factor the denominator as 40 minus v times 40 plus v. And we want to write this as two separate fractions, one with the denominator of 40 minus v and the other with a denominator of 40 plus v. And we need to find the constants a and b so that these two fractions will add up to 400 divided by 40 minus v times 40 plus v, our original fraction there. So we'll go ahead and multiply both sides by the common denominator, 40 minus v times 40 plus v. On the left side, this will cancel out to leave us with the 400. On the right side, we'll get a times 40 plus v plus b times 40 minus v. Continuing on here, we're going to group the terms, the v terms. So we have a positive a minus b times v when I group the v terms together, and then the constants we group together are just going to give us a 40a plus 40b. From this, we can see that there's 0 v's on the left, so a minus b needs to equal 0. And the constant should be 400, so 400 needs to equal, so I'm going to write it in another order, 40a plus 40b needs to equal 400. So the first equation, a minus b equals 0, shows us that a equals b. Putting this into the second equation gives us a total of 80b equals 400. Dividing by 80 gives us that b equals 5, and then going back, we see that a also has to equal 5. This shows us that our original fraction, 400 over 40 minus v times 40 plus v, is equal to 5 divided by 40 minus v plus 5 divided by 40 plus v. So we're going to take this and insert it. Change the color here, give it blue, show you that this is now being inserted for the left side integral. So we'll have now the integral of 5 over 40 minus v plus 5 over 40 plus v dv equals, the right side we can take the integral already. This is going to be t plus some constant. When I take the antiderivative of the left side, we have 5, and I'm going to factor that 5 out of the whole thing. So we'll have the natural log, negative natural log of 40 minus v plus the natural log of 40 plus v equals t plus constant. And then I'm going to divide the 5 to the right side and then combine the natural logs as a single natural log. This will be the natural log of 40 plus v divided by the 40 minus v inside absolute values. This equals t divided by 5 plus some other constant. We'll now exponentiate both sides and get rid of the absolute value. And noting, as we did earlier this term, that the e to the c squared also could be a 0 and give us a solution, we can replace that with an a, or I don't want to use capital A because we use that over on the right. I'm going to change that to a d. This is 40 plus v over 40 minus v equals some new constant d e to the t over 5. All right. We want to find our d value now. So what we're going to do is we're going to take our initial condition, going back to the original problem. We see the initial velocity is 0. So we plug 0 in for t and v, and we get 40 over 40 equals d e to the 0, implying that our d value equals 1. 40 plus v over 40 minus v equals e to the t over 5. And we can go ahead and multiply the 40 minus v to the right. Then we're going to move the v's to the left and the constant 40 to the right. So I have v plus v e to the t over 5 equals 40 e to the t over 5 minus 40. And then I'll factor out a v on the left. So that we can then divide and isolate v of t equals 40 e to the t over 5 minus 40 all over 1 plus e to the t over 5. And there we go. We've solved the differential equation with the initial condition v of 0 equals 0. I'm going to go back to the problem. It had a couple other questions it wanted us to answer. It said find the velocity when the time is 10 seconds, and then the limiting velocity of the boat. So let's go ahead and switch over to purple here for this part of the question. We're going to say the velocity 10 seconds into this boat's run is 40 e to the 10 divided by 5 is 2 minus 40. It's all going to be over 1 plus e 10 divided by 5 again is 2. This will be approximately, we'll just plug this into a calculator. It'll give us 30.46. And the velocity is in feet per second. We now want to take the limiting velocity. So I want to say, what's the limit as the time goes on to infinity of 40 e to the t over 5 minus 40 over 1 plus t over 5. I'm sorry, I forgot the e here. 1 plus e to the t over 5. Now this is going to limit out to just be a 40. And if you want an explanation of that, you can watch the other video that's next to this one. And this is also in feet per second. So now that we've got all of this information, we'll write a conclusion answering the questions posed. The velocity at 10 seconds into the boat's run is 30.46 feet per second. The top speed of the boat is 40 feet per second. That's it.